Our notes today are going to be on antibiotic resistance. They're not going to be very long, but remember, our goal here is to be able to describe natural selection in a variety of examples. So we've looked at the rock pocket mice, we've looked at skin color. This is another example of natural selection in action. So our big question today is, why do some antibiotics become less effective over time? You might not know this. You might not know, that antibiotics, some of them become less effective over time. But I'll tell you a story. When I used to travel, they would prescribe something called Cipro. And Cipro was a drug that helped. It was an antibiotic, and it helped cure traveler's diarrhea. So anytime you were going to a foreign country, they would prescribe you this just in case you got sick because of the water quality or you ate something like that. Fast forward to now, and now if I go traveling to a third world country, they don't prescribe Cipro. Why? Because it doesn't work. So it doesn't treat the bacteria that cause traveler's diarrhea. They've evolved resistance. So this is a topic that you're going to hear about more and more as the years go on throughout your lifetime. So we're going to use a little picture. Feel free to draw a picture like this. This is pretty much all our notes are going to be, is this little like comic strip of a picture. So what happens here is that there's many bacteria. So I usually have people draw a little box here, make some bacteria unshaded, and then one bacteria shaded. And the shaded one represents the resistant bacteria. So remember, natural selection acts on mutations. So the reason that we have variety is because there are random mutations that happen, and because parents produce offspring that are genetically unique. So this guy had a mutation, and it just happened to allow him to become resistant to an antibiotic. We'll say penicillin. So what happens then is, let's say you get sick and they prescribe you antibiotics. Well, most of the bacteria are wiped out by this antibiotic, but the resistant one happens to survive. We've talked about Darwin and his theory of natural selection. His requirements were that there had to be variety, so there's different types of bacteria, overproduction, so only some are going to end up surviving. There's going to be a struggle to survive. Well, all of the ones that are not resistant are going to struggle to survive. And then what we're going to see is that over time the population is going to change. So the resistant ones reproduce, creating millions of bacteria. And now all of a sudden, this antibiotic didn't work. It didn't wipe out all the bad bacteria. You've got an infection again. And so then when you try to take an antibiotic again, it doesn't work because the bacteria are resistant. Now, we've talked about viruses not being so good at copying their DNA and reproducing. Well, bacteria are not very good either. They make lots of mistakes all the time. So the chances that we'll get a resistant bacteria sometime, somewhere, is very high because they make lots and lots of mistakes. And so then this is a problem. What happens then? Well, then we have to try a different antibiotic and hope that a different antibiotic can kill off these bacteria that are causing an infection. So what are the causes? Why is this happening? Well, one of the things that doctors used to do previously is anytime you were sick, they would just prescribe you an antibiotic. Well, antibiotics only work on bacteria. If you've got a fungal infection, if you've got a viral infection, it doesn't work. And so one thing now that doctors are trying to do is make sure that you have a bacterial infection before actually prescribing antibiotics. So instead of just prescribing them for any illness, they can prescribe them just in cases of bacterial illness. Sometimes patients don't finish their antibiotic treatment, and if you don't finish your treatment here, it leaves more room for these bacteria to multiply. Let's say there's more of these white bacteria here that are not resistant, well, then it gives them more of a chance to multiply. And the more times they multiply, the more likely they are to make a mistake and create a resistant bacteria. Farmers use antibiotics in livestock and fish farming, which then contributes to resistant microbes. Sometimes you'll hear about farmers who end up getting nasty infections because their cows were carrying some type of bacteria that was resistant, and then it ended up getting into their skin. Lack of hygiene, poor sanitation. This doesn't really happen in the United States, but that's definitely also a cause. So I would say the top three are probably the most common causes. It's overprescribing, not finishing your treatment, and then just using them a lot in general. And so just for fun, we can take a look at prescriptions of antibiotics per 1,000 people. This is from 2015, so it's a little old, but darker red indicates they prescribe more antibiotics per person. And so that's one of the things we can do to prevent antibiotic resistance from developing is make sure that we're not overprescribing antibiotics.